Right, guys, so welcome back. Let's continue with our experimental chemistry, experimental design. And now we're gonna talk about something very important, a chapter which has been repeatedly asked in the past papers. And there we are, collection of gases. How do we collect different gases and how do we dry the gases? We have to talk about them. And on what basis do we differentiate the collection method of gases? So let's talk about them. Okay, so what are the methods used for collection of gases? Okay, well, there are two major methods of collection of gases. The first one is displacement of water, and the second one is displacement of air. Okay, and displacement of air itself is divided into two types: upward delivery and downward delivery. Okay, so now how do we use each of these methods, or on what basis do we use each of these methods? They are listed right over here. We can collect, how we collect a gas depends upon its physical properties. Okay, the two major physical properties upon which the collection method depends are its solubility and its density. Okay, meaning solubility in what? Solubility in water. Okay, how much it is soluble in water, and density, meaning is it more dense or less dense than air as compared to air, meaning is it denser than air or lighter than air. Okay, because air itself is a collection of gases, so we have to compare this gas to the mixture of gases. Okay, and as a general rule over here, a denser gas has heavier particles. Of course, that makes sense, right? Density, what is density? Density is the ratio of mass and volume, meaning the greater the mass, the greater the density. So now a gas, if is denser than the other gas, then that means its particles are going to be more likely to be heavier than the other particles, than the particles of the other gas. Okay, than the less dense gas. So now, as a rule, this is something I would definitely want you guys to learn, that as a rule, a gas is considered less dense than air if it has a molecular mass less than 30. Okay, and if its molecular mass is more than 30, then that means it is denser than air. And I'll show you the examples, and this is a direct quotation from that same book, Chemistry Matters. Okay, that as a rule, the gas is considered less dense than air if its molecular mass is less than 30, and if it is more than 30, then it's denser than air. And here is an example of what I just quoted. Okay, so ammonia is a gas. Okay, I'm not expecting you guys at this level to know the formula for ammonia, but the formula includes one nitrogen atom and three hydrogen atoms. Okay, so NH3. This is the formula for ammonia. If we were to calculate the molecular mass of ammonia, it would be the atomic mass of nitrogen plus 3 times the atomic mass of hydrogen. That's a standard way of calculation of molecular masses. So nitrogen has a mass of 14 plus hydrogen has a mass of 1 multiplied by 3. So it's going to be 17. Is 17 less than 30 or not? It is less than 30. So that means it is less dense compared to air. Okay. And by the way, the solubility has nothing to do with the density, of course. It depends upon the nature of the gas. Okay, the polarity of the gas. Well, we don't need to go into a lot of detail of polarity over here in O levels, but ammonia, just remember that it is extremely soluble in water. It is soluble in water. Okay, and the reason for that, you'll learn about that in your A levels. It's actually due to the hydrogen bonds, but you don't have hydrogen bonds over here, or it's actually due to the intermolecular forces that they can form in between each other, but again, that's not a part of O levels. So for now, I just want you guys to remember that ammonia is extremely soluble in water, and this table has also been taken from the same book, Chemistry Matters, and I would suggest you just learn it. Okay, that ammonia is extremely soluble in water, and you need to learn this. Okay, then carbon dioxide. What about carbon dioxide? Is slightly soluble in water, but what about its molecular mass? Well, the formula for carbon dioxide is CO2. The mass of carbon is 14, the mass of oxygen is 16, and there are 2 oxygen atoms multiplied by 2. It turns out to be 44, and 44 is more than 30, right? 30 is our standard, and it is more than 30, then that means it is denser than air, and yes, it is. See, it is denser than air. Chlorine, it is also extremely soluble in water. Yes, it is. And by the way, chlorine, when dissolves in water, it forms a bleach like solution, right? It bleaches the solution. You guys must have seen bleach, right? Like greenish type of solution. So yeah, chlorine is responsible for that. And it is denser again because chlorine, the formula for chlorine gas is Cl2. It's a diatomic gas. Diatomic means di means two and atomic means atom. So it has two atoms. So what's going to be the molecular mass of chlorine? If you check out the periodic table, the atomic mass of chlorine is 35.5. And since there are two atoms of chlorine, so it's going to be 2 multiplied by 35.5. So that turns out to be 71. And again, 71 is denser than air because it's more than 30. Now, what about HCl? HCl, again, H and Cl, again more than 30, so denser. Oxygen, slightly denser. Why slightly denser? Because the molecular mass of oxygen, O2, turns out to be 32. And 32 is just slightly more than 30. So that's why slightly denser. And what about SO2, sulfur dioxide? Sulfur is 32 plus 32, 64, again denser. Its molecular mass is 64 more than 30. Okay, so again, this rule of 30 is important. You must know this number. Okay, ever since I was in O levels, I used to be very confused regarding this, which gas is denser and which one isn't. What was that threshold? So this is the threshold. Okay, and this is what's written in the same Chemistry Matters book. Okay, so now I think the job here is done. Now let's move on to the techniques by which the gases are collected and how they are connected. Okay, so now this is the first technique. The first technique is called displacement of water. Okay, displacement of water is a technique and it is used for gases which are insoluble in water. Mark my term, it's used for gases which are insoluble in water, because gases which are soluble in water, they won't be collected. Okay, so let's look at the general setup and then we'll talk about the experiment itself. Okay, we have a delivery tube over here. Okay, this is our delivery tube, and over here we've got an inverted gas jar. Okay, this is a gas jar, again an apparatus, but not very important, but just an apparatus. Just consider it to be any jar. Okay, and it is inverted, it is kept upside down. Okay, the upside is down, meaning the at the top no place is open for the gas to escape. The gas comes and gets trapped over here. Okay, since it is inverted gas jar. Now the gas enters through this delivery tube, it goes down, gets through the water. Since it's insoluble in water, doesn't really dissolve in water, and it turns out and gets collected over here. Okay, but again, this gas is not in a very pure form because it will have traces of water and water vapor with it, because it has come through water. So now it is suitable for collecting gases that are insoluble or slightly soluble in water. Carbon dioxide, hydrogen, and oxygen can be collected by this method. And I would suggest you remember these three examples which have been given in the book. Carbon dioxide, hydrogen, and oxygen. These are slightly soluble in water or completely insoluble in water. They can be collected using this method, displacement of water. And now let's talk about displacement of air. Now these two techniques are used for gases which are soluble in water, okay, which would dissolve in water if they are used by this method. So if they enter the water, they'll dissolve and no gas would come out, no gas would be collected, and again the method would be wasted. Now, so gases which are soluble. Okay, now then why do we have these two different techniques? Why an upright gas jar and why an inverted gas jar? Well, again, the techniques are different on the basis of the densities now. Okay, the gases which are denser than air, they are collected using the downward delivery technique. Why is it called downward delivery? Because this tube, the delivery tube, is moving down, and this is the one on the right is called an upward delivery because the tube on the right is going up. It's called upward delivery. This is downward delivery and this is upward delivery. Okay, now the gases which are denser than air, they are collected using downward delivery, and the gases which are less dense than air, they are collected using upward delivery. Downward delivery should be used to collect gases that are soluble in water and denser than air, such as chlorine, hydrogen, chloride. So just chlorine and hydrogen chloride. Okay, the two examples again you need to remember. Now upward delivery. used for gases that are soluble in water. Again, the same fact, the fact remains the same, but they are less dense than air, and ammonia is a classical example, because remember, for NH3, what was the molecular mass? It was 17, which is less than 30. So yeah, it's less dense than air and can be collected using this technique. Okay, so these are the three techniques of collection of gases. And now we have the technique of drying the gas. How do we dry the gas? And for that, I'll take another video. Okay, I'll come back with this topic in the next video, inshallah. Take care.